This is the last question of 4.1. Okay, so we're going to do one like this because there's one like this on the homework. And I wanted us to see, you know, like it. Because it's a little weird. It's not particularly difficult, but it's a little weird. So what we have here is a polynomial that has a random constant in it, k. And we want to make it, we're going to find k so that f of x goes through this point. So maybe this is our, ooh, that's not a pen. So this is going to be our x value. This is a y value. Substitute. What we're going to do is we're going to substitute this in for y. So we're going to have 4. And we're going to substitute our minus 1 in for our x for all of these x's. And then we're going to solve for k. So we have 3 times negative 1 cubed minus k times negative 1 squared plus negative 1 minus 5k. Dodging. Right? See how that works? Let's figure out what k is. So I've got 4 equals 3 times, what is negative 1 cubed? Negative 1. So we have negative 3. Minus k times negative 1 squared. Yeah. Well, negative 1 squared is positive 1. So we're just minus k. Minus 1 minus 5k, right? Combine like terms. Was it random? What do we have on the right-hand side? Minus 6k. What are we going to do now? Add 4. So it's going to give us 8 equals negative 6k. What does k equal? Yeah. Divide both sides by negative 6. And we get 8 over negative 6, which we can simplify. K equals negative 4/3. So if we were to go back up to this equation, what's up? We could substitute in to the k our negative 4/3, and it would go through this point. So when it has the find k, substitute in your x and y and solve for k. So like I said, it's not super complicated. It's just really weird. It's weird, and it's awkward to kind of wrap your brain around it a little sometimes. But that's all it is. Yes, dear. No, because that's not going to be like a thing. The only time that would be is if we're doing like our factoring stuff, where we're doing our polynomial things. But having 3 variables with a polynomial is like no bueno. But there might be a time when we have more than one k if it's got a k squared. Okay. All right, y'all. We're going to start 4-2. This is the start. And we're going to be doing division with polynomials.
Wait, so we're not doing any more of the problems that we just did?
Nope.
Okay. Because we did all those.
Substitute x and y, solve for k. And there's one like that on the homework, but it's very, 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 very similar. Number 38 on the homework is very similar to the one we just did.
We gotta write them down.
I recommend it. I did not print it, no. And you don't have to necessarily write every word of this. I mean, you don't. So, what this says is we have, if f of x and p of x are polynomials, then we have here, this is called the quotient and remainder. We are going to use this piece today. And honestly, this is the thing that I used in my 600 level class. I used this in my college course like 2 weeks ago. And what we're going to be doing is we're going to be dividing. What this says is if I divide p by x, we're going to get f by p. We have a quotient and we have a remainder. That's a different color. It's just written super complicatedly. So we have a quotient and we have a remainder. We're just going to write them as function rules. And what this is going to be is long division. We're going to be doing polynomial division, which we spent a good long time in Algebra 2 in.
Is that a star after p of x?
Yes, it's a star because like it wouldn't let me put in a multiply. So you could do like a dot. We just don't use an x for multiplication at this level because there's too many dang x's. And I didn't pull out the equation like picture maker.
Why did we ever learn multiply and x? Like why did we do that? We could have just skipped that step. And
I know.
Be a cute little dot.
That would be logical. I don't get to decide elementary curriculum. I wish we could just generally switch it to the dot, but then all the calculator manufacturers would also have to switch it to a dot.
Yeah.
And then we're getting into big calculator and like whole other things and like. But yeah, no, I don't know why. We have x that means two different things. It happens though. The higher you get into math, symbols start to get reused to mean different things, which is super fun. Yeah, totally not at all confusing when I'm using in my college course have symbols that mean different things in my college course than they mean in here. Super fun. Because like absolute value symbols get reused to mean something else. Less than and greater than get reused to mean something else. I don't know. I don't know. Oh, it's so weird. All right. So this is a really complicated way of saying P times Q plus R gives you F. So R is our remainder, Q is what's on the top of our long division, P is what's outside the long division, and F's what's inside. So we're going to be doing long division. I'm waiting. Well, good. You'll be happy today. Because we're doing long division. We will also get into synthetic division. Oh, synthetic division is so much faster. Okay, you can do long division most of the time. It's just significantly longer. I know. All right. So we're going to find the quotient and the remainder if f of x is divided by p of x. So we're going to be doing long division where my f of x goes inside. 9x plus 4. So f of x equals 9x plus 4. P of x is 2x minus 5. So we're dividing like this. She does know you're at school. All right. So whenever we're doing our polynomial long division, it's when we look at our first terms. 9x divided by 2x. We leave it as a fraction because 9x divided by 2x, 4.5 or 9 halves. 9x divided by 2x. Look at just your first terms. 9x divided by 2x. My x's cancel out. We get just 9 halves, right? We put it on top. Yeah. You could, but then we're going to get a weird non-polynomial because it's going to then have x in a denominator. And so we're aiming for polynomials, so we're not going to have x remain, like we're not going to have a rational thing. Because we don't want to have like over x as a remainder. So we're going to then take our 9 halves times this guy. 9 halves times 2x. Nine halves times 2x. 9x. 9 halves times minus 5. Totally fine. You can leave it as a thing. 9. Multiply this guy times this guy. The whole piece. And then we subtract. I agree. This one's kind of a really gross one to start with because it's got all these fractions in it. So then what we do is we subtract this bottom row from the top row. 9x minus 9x. Nothing. 4 minus negative 45 halves. 53 over 2. This is our remainder. Four, and if you put that in halves, it's 8 halves. 8 minus negative 45. So our R of X, thought you were going to have another one, bless you, is 53 over 2. That's our remainder. This guy is our quotient. That's Q of X. So that's what it meant when it said P of x times Q of x plus R of x equals f of x. This guy times that guy plus this guy would get us right back to here. The thing I divided by times what I got on the top plus the remainder should get me back to where we started. Honestly, I feel like this one's harder because they were the same degree. Like the same exponent. So we got all the fractiony weirdness. Like when we have our next one's gonna be 2x to the 4th divided by x squared. We're gonna we'll see. I'll show you. I feel like this one's more complicated because they're linear. It feels really complicated. Yes, you. Times, yeah, put parentheses around it though.
It should equal.
Because if I multiply this out, yeah.
It should equal.
It should equal our f of x, yes. Yes. Okay, so I know this one's super duper weird and awkward because of that fraction awfulness. But all it's saying is that this guy times that guy plus what's left over should get us right back where we started. But again, I feel like it feels really complicated because they're both linear. I honestly feel like this one is less complicated, even though it looks super gross. It looks really complicated, this one. So our f of x is 2x to the 4th minus x cubed minus 3x squared plus 7x minus 12. And our p of x is x squared minus 3. So we are to find our quotient and remainder if we divide f of x by p of x. Two x to the 4th. Minus x cubed minus 3x squared plus 7x minus 12. And we are dividing by x squared minus 3. So we're dividing that one by this one. So look at just our first terms. 2x to the 4th divided by x squared. 2x squared. All right, see that part? Take our first terms, 2x to the 4th divided by 2x squared. We get 2x squared. Then I'm going to take my 2x squared times this whole guy and write it under here. Let me grab my highlighter. So we're going to multiply it times this whole term and put it underneath. 2x squared times x squared gives us 2, ooh, that's not a pen. 2x to the 4th. And 2x squared times minus 3 gives us minus 6x squared. So I'm going to actually write that over here. So it's under my x squared. If you didn't, that's okay too. Just be aware we can only combine terms when our exponents are the same. And then we subtract this whole line from the top line. 2x to the fourth minus 2x to the fourth. They cancel out. It's what we want. Minus x cubed minus nothing. Minus x cubed. 3x squared minus negative 6x squared.
Wait, can you distribute that?
Distribute the what?
Like that sign.
The minus. We are subtracting. Subtract the whole line. So negative 3 minus negative 6.
Oh, 3x.
3x squared. Positive 3x squared. My 7x comes back down. My minus 12 comes down. Round 2. This is where long division starts to get its name, because now we get to do it again. We're going to take our first term and our first term. So minus x cubed divided by x squared minus x. And again, I'm going to take that minus x times this whole piece over here, and now I'm going to write it underneath over here. So minus x times x squared gives us minus x cubed. Minus x times minus 3, positive 3x. And again, we are going to subtract this whole line. There we go. So minus x cubed minus negative x cubed. What happens to my x cubes? They cancel out. My 3x squared doesn't have anybody playing games with it, so it comes back down. 7x minus 3x. 4x. And my minus 12 drops down. And we're going to do one more round of this. So we're going to have our 3x squared divided by x squared. What's 3x squared divided by x squared? 3. So positive 3 is going to be our final term on the top. One more time, I'm going to take that positive 3 times this whole term and put it down under here. So 3 times x squared gives us 3x squared. Minus 9. So when we subtract this whole line, what do we have left over? 4x minus 3. This is our remainder. This is r of x. This piece on top, this is q of x. So our quotient is 2x squared minus x plus 3. And our remainder is 4x minus 3. So when it asks you to find our quotient and our remainder, that's what it's asking. If I was to take this piece times this piece and add that piece, we get back to this guy. That's all that first equation was saying. It just said it in a super duper complicated way. trying to make it so you can say everything. Okay. Well, I mean, that would be multiplying polynomials, which is not really a thing we've done yet, but you did it in algebra. You could. Let me try this over here. Where we like box multiply it. Because you could. I'm not going to write it on the screen, so it'll make my screen super tiny. But I could absolutely take my p of x of x squared minus 3 times my q of x of 2x squared minus x plus 3, and then add my remainder plus 4x minus 3. We could do that. We could do it. I don't want to, but we could. We would have to do a whole lot of distributing and then combine some like terms, but it would put us right back at f of x. But that's like a algebra 2 question, a hard algebra 2 question versus a pre-cal question. Okay. So long division, we just kind of remember how to do long division. Okay? I'm going to give us one more theorem for today. All right. The remainder theorem. Yes. What this is a synthetic division shortcut. Using synthetic division to be a shortcut. So I had to clarify that because I knew you got excited. I'm like, you're not be excited on it.
I think I like missed the day we learned it, and so I had to come back and like.
That makes it really tricky. All right, so synthetic division is where we take all our coefficients, and then instead of doing subtraction, we do addition. And all this is saying is that when I do synthetic division using my root, whatever the remainder is the same answer as if we substituted it in. So what we're going to do here is we're going to do synthetic division. So we're going to remember synthetic division now. If we are going to divide by x minus 3, what I need is my root. What is the root if my factor is x minus 3? 3. My root, my 0, my solution. Same, guys. So if my factor is x minus 3, my root is positive 3. So setting up our synthetic division. That's a wonky line. This guy. We put our root outside. Has to be the root. Inside we put our coefficients, smallest to biggest. So my coefficient for x cubed is what? 1. My coefficient for x squared, negative 4. What do I put next? Do you remember? This is x squared. What's my coefficient for x? 0. We can't skip anybody. And then my constant goes at the end, minus 5. So you have to have constant x, x squared, x cubed. If you've got more terms, you got to include everybody up to your biggest. You cannot skip anybody. When we're doing synthetic division, the first term always drops. Every single time, first term drops. This times this goes here. 1 times 3. The bottom, so what's underneath? Down here. This piece times this piece goes in the box. And then we add. Add down the column. So -4 plus 3. -1. -1 times 3. -3 goes in that box. Or in that space. Okay. Yes? -1 times +3 gives us the -3. Okay? I know it's been a hot minute since we did synthetic division. I know it's been a hot minute. That's okay. That's what we're here for. Okay? And then with synthetic division, we add. So 0 plus -3, -3. So add. It's just the coefficients. No x's. Multiply, add, multiply, add, multiply, add, till we get to the end. So then we're going to multiply -3 times 3. Put it underneath the 5. She what? My mom ear's triggered. Somebody hit. Use the filter between your brain and your mouth and don't cuss in my classroom, please.
I never said it. I don't want to do that.
Someone dropped an F-bomb. It was quiet. It was quiet. But my mom ear's triggered. All right. Last one here. -5 plus -9. -14. This last term is always the remainder. So to do this division, what our quotient would be, this is the new constant, this is the x, this is the x squared. So to write this as an equation, we'd have 1x squared minus 1x minus 3 is our new quotient. This would be q of x if we wanted to find that. We weren't asked to find it, but I was just reminding us of what it is. When we're doing our synthetic division, if we want to get the polynomial, we get this. All we were asked to find is what is the remainder? -14. This tells us f of 3 equals our remainder, -14. That is what the remainder theorem tells us. F of your root is whatever the remainder is in synthetic division. Yes, we can do another one. In fact, we're going to use the same polynomial, but a different root. So our next root is going to be, or our next factor is x plus 2. So it's the same polynomial, different factor. So same polynomial, different factor, and this will probably be our last one for today. Just because I don't want us to have to rush too hard. So we're finding the remainder if this is divided by x plus 2. So again, I'm going to set up my synthetic division. It's going to have our coefficients. Again, it's 1, -4, 0, and -5. Because I got to have a term for every exponent. Even though I have no x's, I still need to have a coefficient there for it. When we're doing synthetic division, we have to have our root This is a factor, not a root. What is our root? -2. So -2 is what goes over here. Any questions on the setup part? Because all that is a setup. First term, drops it like it's hot. Drop it like it's hot. Drop it like it's hot. Drop it like it's hot. So the first term always drops. Every single time that first term will drop. Then we're going to take what's underneath times our root and put it here. So 1 times -2 goes here, which is -2. And then we add -4 plus -2, -6. What's going to go here? Positive 12. I was going to say, you said the right thing. You just didn't quite, finish the operation. -6 times -2, positive 12. And then we add $12. Yes. That's the final answer. So what's going to go here? -24. And so what is our remainder? -29. So what that tells us is f of -2 is -29. That's what the remainder theorem tells us. We could write the quotient out again, which I'm going to do that so we can practice that. Q of x is our 1x squared minus 6x plus 12. That would be our quotient. Our remainder, r of x, just use our same verbiage, is -29. That's all we have. Our p of x was x plus 2.
It's a show on Netflix.
All right. So we'll continue working with our synthetic division stuff tomorrow. We'll work more with it tomorrow. Okay? You guys have, that's not what we're doing. Go in here. There we go. We are going to be doing a quiz on Thursday. It's on the sheet. You don't even get to be surprised. So you can start on homework 4.2. Homework 4.1 is going to be due tomorrow since we didn't finish up the last question of 4.1 until today. So turn in 4.1 tomorrow. If you get it done today, totally fine. You can always turn it in early. I'm going to go with happy birthday.
Yes.
Okay.